Hello everyone, Samuel here. Welcome to the third part of this short video series where we are playing with Cisco NSO. In this one we are going to start the SDN-C component from ONAP, connect Cisco NSO to it and create and execute some directed graphs. As before, this video can be also found in text format on our company blog. The link is in the description. SDN-C stands for Software Defined Network Controller. Yeah, there was not much originality put into that name. It is a component from ONAP designated for communication with the underlying network. SDN-C is based on another component called CCSDK, which means Common Controller Software Development Kit. Again, very original name, but hey, you cannot say it doesn't fit its purpose. CCSDK contains a minimal distribution of OpenDaylight consisting of the ODL controller, netconf sub1 plugin, restconf normal plugin and some other modules. If you saw the last video in this series about Light.io, these were the same components we started with before. CCSDK adds certain features to this ODL distribution. Most notable is support for directed graphs. You can think of them as a visual way of teaching CCSDK new things without coding during runtime, which is really cool but a bit cumbersome and problematic to develop and debug, as you will see in a second. It's kind of visual programming where you can drag and drop elements representing functions on a canvas. Then you can connect them, modify them, parameterize them, and in the end you can create your own functionality. For example, later in this video we will create a directed graph to activate the NSO service. In this part we will need the Cisco NSO instance again. We started it with 3 simulated devices in the first video in this series. Next we will need Docker installed to start SDN-C, and I'll use Postman as a REST client. As before, my operating system is Ubuntu Mate 18.04 LTS release. Let's start SDN-C now. It's quite easy with Docker. We will use the official ONAP Docker images, which will be downloaded directly from Docker Hub. To make life a little bit easier, we will use Docker Compose. The one I'm using is based on the Docker Compose file from the SDN-C Git repository, but it's quite minimal. It's stripped of some unnecessary parts for this video. This Docker Compose file can be downloaded via link in the description. The most important Docker images are SDN-C image and CCSDK DG Builder image. SDN-C image contains an implementation of the SDN-C component based on a combination of CCSDK and ODL. DG Builder image contains a web UI which is used for designing, uploading and activating directed graphs. Versions 2.0.4 and 1.0.3 correspond with the ONAP Guilin release. The next important configuration for us is port forwarding. SDN-C will be available at port 8282 and DG Builder at 3000. To start all of these Docker images, execute command docker compose up. After some time, we should see a message that Karav is started and it has a number of bundles active. As mentioned before, DG Builder is available at localhost at port 3000. Default username and password to get in is dguser and test123. Let's head there and create custom directed graph to get and print information about device connected to the SDN-C. Every directed graph must start with a node called dgstart. Drag it from the left side panel to the canvas. Next, the service logic and the method nodes must come. Drag them on the canvas too. There is a little trick. While dragging nodes on the canvas and holding Shift button on your keyboard, nodes snap to an invisible grid and it's much easier to align them. Now connect nodes on the canvas by clicking and dragging those small gray dots at their sides. To configure nodes, double-click on them. Configuration window will appear. In the service logic node, we need to specify module and its version of the directed graph. For this video, we will use NSO operations version 1.0. Press OK to confirm the configuration. Now open a configuration of the node method. Other nodes than the service logic use XML configurations. Lot of times, default template will be present in the node configuration or it can be seen in the info panel on the right side of the screen. In the configuration of the method node, we need to fill a name of the directed graph. This one will be called getNSO. Fill it into the parameter RPC. The name of the node defines only with which name will be element shown. It does not affect functionality of the directed graph. It just makes directed graphs easier to understand. So let's call this with the same name as the directed graph itself. With these 3 nodes, configuration of this directed graph is ready. We can implement the logic now. As hinted before, this directed graph will be used to get and print information about the device connected to the SDN-C. To get this information, we will execute a RESTconf GET request on the ODL data store. Path will point to the operational data store where the device information is stored. This path will be parameterized, where the parameter will be the ID of the device. We will store response from this RESTconf request in a variable, and after that we will print to the console some information from the response. The RESTconf request can be executed by using a node execute. Drag it to the canvas and open its configuration. I'm copy-pasting the XML configuration here because it's pretty long. Links to all of the directed graphs shown are in the description. Feel free to copy-paste them too, or just play with them. In the first line of the configuration, we need to specify which plugin and which method we want to execute. We are going for a REST API called node, plugin, and send request method. Next, in the parameter response prefix, we need to specify name of the variable where will be the response stored. In the next few parameters, we need to specify RESTconf request details like a format, HTTP method, credentials, and URL. Credentials used are defaults for the SDN-C ODL. As mentioned before, the URL points to the netconf node in the operational data store with parameterized node ID. As a last thing, we can call this node getNSO node. Every execute node can have multiple outcomes. Outcomes are the way of handling possible errors during execution of the execute node. More information about when are which outcomes thrown can be found in the info panel on the right side. In this case, we will catch 2 outcomes: success if everything went OK and other for every other outcome. Drag them from the left side to the canvas. Connect all dots together. At first, let's handle other outcome. We will just return a failure by using the node return failure. In it, we can specify an error code and a message. Let's go with the error code 500 and the message like this. Click OK and connect it to the other outcome. For the success outcome, we will execute a block of nodes. They will be executed in an order as they are placed vertically on the canvas. In this block, we will execute 2 record nodes and 1 return success node. Drag them all to the canvas and connect their dots. Now open the configuration for the first record node. Again, I'll copy-paste this configuration. As a record plugin, we will use a SLF4J recorder, which is able to print logs to the console. In parameters, we will specify some additional information like a level of the log and a message itself. In the first one, we will log to the console an ID of the node we got from the RESTconf request. We will get it from the variable response using following path to the node ID. Second record node will be very similar to the first one, but instead of logging a node ID, we will log a connection status. And finally, in the return success node, we can return some message if needed. In this case, we will skip it and just remove that parameter. That's it, directed graph is completed. Now we can validate, upload and activate it. In the DG Start node at the beginning of directed graph, there is a small button at the left side. Click on it and a new window will pop up. Here you can see the XML representation of whole directed graph. At the bottom there is number of buttons. With the download JSON button, you can download directed graph exported in the JSON format that can be later imported. We will import another directed graphs in a moment. Now click on the Validate XML button. If everything is OK, a small green message at the top of the screen will appear. To further validate and upload this directed graph, click on the Upload XML button. If something is wrong with our graph, error message will be present. But in this case, directed graph was uploaded successfully. To activate it, click on the View DG List button, then at the Activate text in the middle of the screen, and then again on the Activate button. Now our directed graph is activated and is ready to be executed. But first, let's import some other directed graphs. They can be downloaded via links in the description. Open New tab by clicking on the plus sign, click on the menu button in the upper right corner, hover over the import button and choose the clipboard option. Copy-paste here a content of the exported Connect NSO directed graph that can be downloaded from the description and click on the OK. Now just click on the canvas to position whole directed graph. Validate, upload and activate it as we did with the previous directed graph. There are a few new things in this directed graph we can go through. First is a set node called createPutRequestBody. It is used to create or set variables that will be usable in the rest of the directed graph. As the name suggests, this one creates a payload for the put request to connect to the NSO instance. As you can see, it's pretty ugly one-liner because there is a lot of characters escaped and it's parameterized. Parameters used are node ID, node address, node port, node user, and node password. This putRequestBody variable is then used in the putNSO node as a payload. Another new node is a call node called callGetNSO. It is used to call another directed graph. This one in particular calls the getNSO directed graph we created together before. Now repeat import and activation procedure with the activate ACL directed graph. Click on the menu, import from clipboard, copy-paste the JSON, click on the OK, click on the canvas, click on the digistart node, validate the XML, upload the XML, click on the view DG list, activate and activate again. Feel free to look at nodes in this directed graph. It executes put resconf request to activate ACL service. Everything is very similar to previous directed graphs we went through. Okay, in this state we have 3 active directed graphs: the Connect NSO, the Get NSO, and the Activate ACL. Before we start executing them, open the Carve console to see logs from our graphs. To do that, execute command docker exec it SDN-C controller container /bin/bash. Move to the opt OpenDaylight bin directory and execute client script. It gets us into the Carve console. To clear and open logs, execute commands log clear and log tail. We will come back to this log once we execute directed graphs. We will need one final thing, an IP address that will be used to connect the SDN-C to the NSO. We cannot simply use localhost as before, because the SDN-C is running in a Docker and the NSO on our local machine. To get this IP address, execute command docker inspect SDN-C controller container and at the end look for gateway field. Now finally, we are going to execute our directed graphs. Directed graphs are executed using RESTconf requests. For this, I will use the Postman application. As in the previous video, I prepared the Postman collection that you can import. Link to it is in the description. At first, open a request for connecting NSO. In the URL, you can see that we are going to execute a RPC called executeGraph from the SLI API module. This is how directed graphs are executed. As an input, it contains a few fields. The module name and RPC name specifies which directed graph we want to execute. In the field SLI parameter, we can define multiple input variables for the directed graph. For Connect NSO, we need to specify the node ID, node address, node port, node user, and the node password. Here we need the IP address we got before with the docker inspect command. The value is set in the node address parameter. You may see a different address as opposed to what I have. The parameter node ID specifies how we want to call this node. Other parameters have the default values. Hit send to execute this RESTconf request. We got an OK status. Switch to the Carve log we opened before to see if it printed what it should. If you recall, the directed graph Connect NSO was calling getNSO init. At these lines, we see output from the getNSO directed graph. Here it tells us that the node ID is NSO and the connection status is connecting. When we execute the directed graph getNSO again via Postman, we can see that the connection status is now connected. The final step is to activate the ACL service. In the payload of the corresponding Postman request, you can see various input parameters. They will be used as an ACL configuration in the directed graph. To check if the service was really activated, we can execute the restconf get a request to read a list of services from NSO. Open the get list of services Postman request and hit the send button. In a response, we should see one entry in a list with the name ACL from DG. That's the one we activated using our directed graph. And that's all I wanted to show you in this video. We started SDN-C in a local environment, created and activated a few directed graphs, and then executed them. So thanks for watching and have a nice day!